With polymorphism and let type, we can make some interesting programs. In this code block below, we declare a polymorphic type for lists, and then we have a polymorphic function to take the length of a list. Let's go through this code step by step. Overall, we have let f, which has type for all a, function a to int. And f is equal to this big fun of a with the body inside of a little fun, which takes in a v of type a. And finally, at the end, the result of calling f will be the value of this call to length with two cons pairs and then an empty on the inside. Over here at the bottom, we call f 2 times. First instantiated with int and then applied to the value 10. Second instantiated with int arrow int and applied to an identity function. Okay, we can call f with 2 different types and get back 2 different lengths. How does it work on the inside? We've got a let type for list, and a list is either an empty or a cons, and each of these 2 variants takes exactly 1 argument because that's the kind of let type we have in Mo. Empty takes in 1 int, cons takes in a pair, first of an alpha and then the rest of the list. Then, having defined list, we immediately define a recursive length function, which matches on an input list, checks for the empty case or the cons case, and counts the number of conses. There we have it, a polymorphic type and a polymorphic length function. The problem here is that if we wanted more polymorphic functions in addition to length, they would all have to be declared right inside that big fun with the list data type. If we wanted to reverse a list, we would need to put a reverse function right inside this block. If we wanted to sort a list, same thing. All those functions have to be declared right at the same time when the list is created, because they all need access to this big fun bound parameter, this type variable a. That's a problem that we don't have in Split, so let's see if we can upgrade Mo. For that, we'll need to change how let type works so that it incorporates some of the abilities that we got from Big Fun. We'd like to be able to say let type list of alpha. So whereas before we had to give only a type name here, something like list, now we can give a type name and a type variable to abstract over. Here we've got something close to the length function that we want. This one is specialized to ints. But the point here is that it can use the list of type that we just declared, and then we can call that down below, as long as we instantiate each one of the constructors. The length that we really want is on the next slide. Here we've got a length which, for any alpha, takes in a list of alpha and returns an int for the length. This len function, as we'd expect, starts off with a big fun, and then it has a little fun to take in the list of alpha. Down below, we call length twice, and we need to do 2 sorts of type instantiations for this. First, to supply that argument to the big fun for len. Second, to supply the type for the constructors, cons. That's a lot of types, but once we fill them in, then this call works out. Next up, we'll see what we can do to infer the types for these type applications. For reference, let's take a look at the same code in Split to see where we'd like to end up. So here's a Split type for polymorphic lists. We've called it myList here to avoid clashing with Split built-in list, and it's got 2 variants, and each variant, just like Mo, has exactly 1 field argument. The empty case takes in an int, and the cons case takes in a pair, which combines an alpha and the rest of the list. Here's a Split length function, which works on polymorphic lists. Take in a list x's, match on the list. If it's empty, the length is 0, and if it's cons, the length is 1 plus the length of the rest of the list. And then we can call polymorphic length on 2 kinds of lists. First, a list with integers inside, and second, a list with functions inside. It all works out. Let's run it. Yes, we have 2 and incomplete test coverage. But now the thing I want to point out here is we've got very similar type definitions and function definitions that we had in Mo. But this time, len does not need a big fun on the outside. Our applications of len don't need to supply a type. Split can figure out where the big fun belongs and where the type application should go and what types should go into those applications. Our next goal is to power up Mo so that it can do the same sorts of inference.